In the vast expanse of space, among billions of stars and planets, there's a world that is both familiar and alien. This is Venus, our closest planetary neighbour, a celestial body shrouded in mystery and promise. At first glance, Venus is strikingly similar to Earth. It has almost the same size, mass and composition. Both planets formed from the same cosmic cloud of dust and gas, both orbiting the same star. Early astronomers, gazing at Venus through their primitive telescopes, dreamed of a world much like our own, perhaps even home to life. However, this resemblance is deceiving. While Earth is an oasis of life, Venus is a lifeless inferno, an inhospitable world of extreme temperatures and a toxic atmosphere. What went wrong with Venus? How did a planet that may once have been so similar to our own become such an inhospitable place? And what lessons can we learn from the fate of our sister planet? Venus has long captivated the human imagination. Ancient cultures revered her as the goddess of love and beauty, her shining presence gracing the morning and evening skies. But beneath her celestial splendor lies a story of violence and upheaval. Venus's surface is a scarred testament to volcanic activity, covered in vast plains, carved with towering mountains, and dotted with thousands of volcanoes. These volcanoes have spewed enormous amounts of lava and gases throughout Venus's history, shaping its landscape and poisoning its atmosphere. By studying Venus, we hope to unlock the secrets of its turbulent past. We want to understand the forces that shaped this planet and led it down its current destructive path. And perhaps most importantly, we seek to learn whether Venus was ever home to life and whether it could be again. The surface of Venus is a harsh and unforgiving landscape. Temperatures here soar above 860 degrees Fahrenheit, hot enough to melt lead. It's a hellish landscape bathed in a dim orange light filtering through the thick clouds. The atmospheric pressure is crushing 90 times that of Earth, equivalent to what you would experience nearly 3,000 feet beneath the ocean's surface. No spacecraft has been able to survive on Venus's surface for more than a few hours. The extreme heat and pressure quickly disable even the most robust landers, their electronics failing and metal structures melting and warping. This is a world hostile to all known forms of life. The atmosphere of Venus is a poisonous shroud, further compounding the hellish conditions on the surface. It's composed primarily of carbon dioxide, a potent greenhouse gas that traps heat and contributes to the planet's extreme temperatures. Thick clouds of sulfuric acid blanket the planet, reflecting sunlight back into space and giving Venus its high albedo. These clouds also produce rain of sulfuric acid, although it evaporates before reaching the ground due to the intense heat. Venus's atmosphere is a death trap, a place where life as we know it cannot survive. Its dense composition and extreme temperatures create a relentless cycle of heat and pressure, making Venus the hottest world in our solar system, even hotter than Mercury, despite being farther from the Sun. Section 5. Venus's Lost Oceans. Despite its current inhospitable state, some scientists believe that Venus may once have been a very different place. Computer models suggest that Venus may once have had oceans of liquid water on its surface, much like Earth. This water may have existed for billions of years, creating a more temperate climate, potentially suitable for life. However, the fate of these hypothetical oceans remains a mystery. One theory suggests that increased solar luminosity led to a runaway greenhouse effect, causing the oceans to boil away, leaving behind the dry, overheated surface we see today. As the water evaporated, it entered the atmosphere, further intensifying the greenhouse effect and locking Venus into a cycle of irreversible warming. Section 6. Venus's Trap, the Deadly Greenhouse. The fate of Venus is a sobering reminder of the delicate balance that makes life on Earth possible. The greenhouse effect, while a natural process that helps regulate our planet's temperature, can spiral out of control if too many greenhouse gases are released into the atmosphere. This is precisely what happened on Venus, transforming it from a potentially habitable world into the inhospitable desert we see today. By studying Venus, we can gain valuable insights into the dynamics of the greenhouse effect and how it can shape the fate of planets. By understanding the mechanisms that led to the runaway greenhouse effect on Venus, we can better protect our own planet from a similar fate. Section 7. Dreams of floating cities. Despite the horrific conditions on Venus, some dreamers have dared to imagine a future where humans could inhabit this inhospitable planet. One such concept is the idea of floating cities, giant airships that would hover high above the scorching surface in the cooler layers of Venus's atmosphere. At these altitudes, the temperature and pressure are more forgiving, potentially making human habitation possible. These floating cities could be constructed using advanced materials capable of withstanding Venus's harsh conditions and powered by a combination of solar and wind energy, which is abundant in the planet's upper atmosphere. They could serve as platforms for scientific research, mining operations, or even as a refuge for humanity in the event of a catastrophe on Earth. Section 8. The challenges of Venus exploration. However, colonizing Venus, even in the form of floating cities, is a monumental task fraught with numerous challenges. The extreme heat, pressure and corrosive atmosphere present formidable technological hurdles. Transporting materials and personnel to Venus would be a costly and dangerous undertaking, requiring the development of new propulsion systems and life support technologies. Moreover, the ethical implications of colonizing Venus are a subject of debate. Do we have the right to attempt to terraform another planet, potentially altering its environment for human benefit? And what would be the long-term consequences of a human presence on Venus for the planet and its ecosystem, if any exists? Section 9. Lessons from our sister planet. Despite these challenges, the study of Venus remains a crucial endeavor for the scientific community. By studying our sister planet, we can gain valuable insights into planetary evolution, the dynamics of the greenhouse effect, and the potential for life on other worlds. Venus serves as a sobering reminder that even seemingly Earth-like planets can have vastly different fates, and that our own survival on Earth is not guaranteed. Venus, once a beacon of hope for life beyond Earth, now serves as a cautionary tale. Its fate underscores the fragility of our own planet and the urgent need to address issues like climate change, which threaten to disrupt the delicate balance that makes life on Earth possible. By studying Venus, we can better understand our own planet and take steps to protect it for future generations.